Hello viewers, today we will speak about this B problem of Codeforces round 1077. Here basically we are given a binary string which contains zeros and ones, and what these zeros and ones represent are, imagine that there is a bench of students where students can sit. For example, there are lots of spaces for students to sit. Here 0 means that there is no student in this position, and 1 means there is a student in this position. So we'll have to keep adding students in this bench until this bench is fully filled up. But there is a condition that no two students can sit next to each other. We'll have to maintain this, and after filling the whole bench we will have to calculate the total number of students, minimum total number of students seated when it is impossible to sit anyone else in the row. For example, if there is no student here, and there is a student, and there is no student here, can we add any other student here? Actually yes, we can add a student here and a student here. So the total number of students that will be in this bench are 3, and you can see that there is no two students are next to each other. That's the condition we'll have to maintain, and finally we'll have to say, we'll have to print the total number of students, minimum total number of students that will be in this bench. That's our job, to calculate this. So first of all, let's imagine a situation here. There are a couple of situations here and I'll explain one by one. First, look at the condition 1 where the binary string is full of zeros, meaning there will be no 1. So in this situation, how many students we will have to add, and how many students, and we'll have to remember, we'll have to minimize the number of students we will add. So think about it, how we can reduce the number of students we will add. If we add one student here and then we add another student here, then the total number of students that are added are 2. And you can see that we can add no more students here, and if we add any more student here, then the condition will be false because no two students can sit next to each other. So we have reduced the number of students. We could have added one student here, but it will increase the total number here. So we will add here, and then after 2 positions we will add another student here, and that's how we reduce the number. Imagine another situation where the total vacancy are like 3. So if we add a student here, then the total number of students added are 1. And actually this number means the previous existing students plus new added students. So if all are zeros and the number is actually divisible by 3, if you can notice the number is actually divisible by 3, then we actually divide the number by 3, and that's how we get this number. But what about other cases here, like when the number of zeros are not divisible, is not divisible by 3, like this one? How many students we will have to actually add here? So if you notice, if we add one student here, then there is still a scope where we can add another student, and that is this position. You can think about another case, like if we add a student here, then there is another scope where we will have to add another student, and this is this position. So Let's take another example to look deeply about this matter. Another case where the number of zeros is not divisible by 3. Like here the total vacancy is like 5. So if we add one student here and then we have another student here, then the total number of students will be 2. So what you can observe is that this number is actually number of zeros divided by 3 plus 1. You can you can try more examples and you'll find out that this is the way we will have to find out the total number of students that will be added. And if it is divisible by 3, then total number of students that will be added is number of zeros divided by 3. This is the complete situation of the condition 1. Now we will see another condition. Let's take another example. How many students we will have to add here to fulfill the condition, the given condition? If you observe carefully that we will have to just add another student here and the total number of students will be 3. And this is the least number of students that will have to be present here to meet the condition. And if we add another student here, then the condition will be break that no two students can sit next to each other. So let's take another example. How many students we will have to add here so that the condition is fulfilled? If you notice carefully that we will have to just add one more student here and it will be the least number of students. Another example, 4, 5. Again, you will see that we will have to just add one more student and the total number of students will be 3. So what you can observe is that here the total number in between the two ones, the total number of zeros are here 3, here 4 and here 5. So if you see the pattern that 3 divided by 3 is equal to 1, so we just had to add one more student and this will become 2 plus 1 is equal to 3. And you can see that 4 by 3 is equal to 1. If we divide integer divided by integer, then it will be 1. Then 2 plus 1 is equal to actually 3. And again 5 by 3 is equal to 1 and 2 plus 1 will be 3. But if we add, if there is one more space in between like 0 0 0 0 0 0, then here the total gaps are like 6. So 6 by 3 will be 2. So the total number of students will be 2 plus 2 is equal to 4. And you can just verify this, that if we add one student here, then there is a lot more spaces. So there is a scope to add one more student. And we will have to add this here. So the total number of students will be 4. So this is the equation when there is a 1 in front and there is a 1 in back, and in between the total number of zeros divided by 3, this number will be the number that we will have to add to the existing students, is the existing number of students. So this is the condition 2. There is one more condition left, and we will have to think about this. Condition 3. Let's take an example. In the previous condition, we dealt with this situation, and we know that we'll have to just add one more 1 here to satisfy the condition. But what about another case, like if we have another space in front, then what will be our answer? We'll have to add one more student here, and that's it. The total number of students will be 4. But this segment, if you notice that there are 3 segments of zeros, and we dealt with this portion like the total number of zeros divided by 3, right? But we'll have to actually deal the first segment of zeros and the last segment of zeros in a different way. This number, that actually the total number of zeros here is actually 2, but this number is not divisible by 3, but still another student could be added here. So that's why we added it to fulfill the condition. If the number is 1, then we don't have to add one more student. But if the number is actually 2 and this number is not divisible by 3, then we have to actually add one more extra student here. Let's take another example to understand this better, like 0 0 0 4 1 0 0 0 1 0. Here the total number of students, the number of students we'll have to add actually is 1. But what about this segment? We'll have to actually add 2 students here and here. Observe that after adding 1 student here, there is still one space left to add student. So we'll have to add one more student here to satisfy the condition. So for the first segment of zeros and for the last segment of zeros, if the the modulus of this number, the number of zeros here, let me write down the equation for this. If this is 2, then we'll have to actually add one more student to fulfill the condition. So these are the 3 conditions that we will have to say to solve this problem. Let's look at the code part. I have declared long n and a string s, and I have taken this input, and then I have counted the total number of zeros and ones, and if there is not a single character 1 here, meaning in this condition, then it falls into the first condition that we discussed, meaning there are all zeros and there is not a single 1 character. So we increase the total number of students, the total number of zeros divided by 3, and if the total number of zeros modulus 3 is equal to 2 or modulus 3 is equal to 1, then we increase the total number of students. And we saw why we do this. Then we calculated the first segment of zeros in this loop, and we saved it here in the first 0 variable. This is saved for the and we will see why we saved it and this means actually the first segment of zeros, the total number of zeros in the first segment. And then we calculated the number of zeros in the middle portion. In this loop we calculated for the middle portion and we increased the total number of zeros doing this c divided by 3. C here means the total number of zeros in the middle portion. And finally in the last portion we increased the total number of students by doing c by 3. This means for the last segment, the total number of zeros divided by 3, and we saw that why we increase it by 1 if the total number of zeros modulus 3 is equal to 2. And for the first segment again the same scenario, that the total number of zeros percent 3 if it is 2, then we increase the total number of students by 1. So that's the answer. Thanks for watching.